Some people sent questions and comments, and I'm going to be answering some of those. This is the first thought. It says, science is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through what? Observation and experiment. And yeah, they always want to put that experiment in there. But see, experiment doesn't tell you. Neither experiment nor observation, gawking, doesn't tell you anything about how the universe works. You have to figure that out. You have to try to, imagine how the universe works, especially when you're dealing with invisible and intangible mediators. Whatever mediates light, whatever mediates gravity, magnetism, those are invisible and intangible. You can't touch them. You can't. You can detect them through some equipment, but the equipment cannot tell you what it is. So all you can really measure is the visible stuff, see the visible stuff, touch the visible stuff, but not the mediators, which are invisible and intangible. So no, observation and experiment will not elucidate what the mediators are. And that's what we need in order to give a physical interpretation to a phenomenon, to a mechanism. Okay, and so, yeah, observation and experiment is not enough. In fact, it's the difference between a detective and a prosecutor. Detective goes out there and does all kinds of work, and that's fine. They do their research, they look for clues, fingerprints, whatever they're looking for. Then they come back, they give it to the prosecutor. In science, it's the prosecutor who is the scientist. Okay, it's the guy who has to deliver his speech to the jury or whoever, to the crowd, and tell them what the mechanism is, what his theory is. Okay, and obviously, he can't run an experiment and say, look, here's the experiment. And who cares? So you did an experiment. You don't know, what you did, but you did an experiment. Great show, No, you have to explain the trick, how the magician did the trick. And this is the problem with just doing observation and experiment. This is what we've been doing for the last 400 years. In fact, really since the days of the Greeks, we've been doing observation and experiment. And less with the Greeks, they did a little more visualization. But it turns out that they never figured out gravity or light in the last 2,500 years. So, yeah, you need a little more than just the experiment and observation. What you need is visualization. You need to imagine, how this universe works. And you won't be able to do that by running an experiment. In other words, the experiment will not really elucidate. You have to do the work. The experiment will not tell you. And that's where people don't always understand. It's running an experiment is just fine. You can do an experiment, but then you have to interpret the experiment. That's where science comes in. That's where you have to break your head. How did Mother Nature do that magic trick? Very simple magic trick. Here we have a little spoon, okay, and we let go of it. Here we go, and it falls to the floor. Well, you can do experiment all the time. You can observe this all the time, right? And what's it going to tell you? It's not going to tell you how Mother Nature pulled this or pushed this down towards the center of the earth. That's the issue. You got to find out how the trick is done. That's science, physics. Okay, another fellow says, I would suggest daisy chaining. It solves some problems. It also necessitates constant rerouting, which may explain some other things. Yeah, daisy chain means, in the context of atoms, is that they're all chained together somehow. They're all bound to each other somehow, okay? And that's what we do here. We're suggesting essentially daisy chaining, okay? That's our model there. They're all connected. And they're all connected by a straight mediator. Really, it's not even straight in the sense that it's a wound. It's a double. It's DNA-like, but it's pulled tight. It's drawn tight. It's taut. It's a taut rope that mediates between any two atoms. And when you look at that, if you look at all the atoms in the universe, it's a daisy chain. So in a sense, this fellow is suggesting that, yeah, this is our model. This is what he's suggesting, that our model is correct in his view, right? Okay, and with this, yeah, we can explain lots of things. We can explain gravity, because gravity is a pull force, and you can't pull without a mediator, so what are you going to put as a mediator? And we're saying, yeah, there's a rope there. Okay, we can all imagine just a simple string here, you know, and if these are my fists are the atoms, and they're pulled tight, you know, then we can all imagine why this atom can pull on that one. At least you can imagine. But if you let go of this and you have this, which is what quantum proposes, well, how does this atom pull on that one? There's nothing in between. You know, so this is the issue. You have to put something in between there. That's what nobody has done in the last 2,500 years. And another fellow says, the word atom is derived from ancient Greek adjective atomos, meaning uncuttable or indivisible. That's what atom means, yeah. We have divided it into over 200 of the subatomic particle zoo with the accelerator colliders. And there's your atom, hydrogen atom. How do you divide it? Are you going to divide it by pulling the electron out of it, or or divide it in half? I don't know. How do you divide that atom there? See, and that's the problem. And we have a different kind of atom, and we can talk about dividing our atom, but our atom is indivisible. Here's our atom. Looks more or less like that. A bunch of rays concentrating at the center, which is the proton, what we call the proton star, the proton dandelion, the urchin-like center, and all the lines, all these threads stick out all the way to the end of the universe, and the atom, and then what encapsulates this is that electron shell, which is made out of the same threads. And so it's pumping back and forth, doing its quantum jump. Okay, that's how we visualize it, and we say that this atom is at least a rational one because it's a physical object. Here you have two atoms, okay, 2D and 3D version. They're doing their quantum jump. They're torquing the rope while they do so. How are you going to divide these? I mean, what's the mechanism? And here you get probably a better view of how this might look in reality, something like that. Something united, with a rope between them, rope-like entity between them. Okay, and here's maybe what the hydrogen molecule might look like, the H2, something like that. Okay, so they're bound. The shells have merged, and they're vibrating. And so, this is something you can at least visualize, and which is consistent with what observation and experiment, right? In other words, this doesn't violate anything that we have out there. We're saying it's a physical object vibrating. When they're farther apart, they have the rope between them, and they torque the rope. When two hydrogen atoms get very close, if they're going in the same direction, they kind of screw into each other, and they form this figure eight molecule, the H2 molecule. So we're consistent with what's out there. Okay, another fellow says, illogical absurdity. Okay, says Charles Steinmetz wrote in his 1914 second edition, Electric Discharges, Waves, and Impulses, and this is what he wrote: the electric field is made up of both the dielectric and the magnetic, making the electric thread the child. Okay, we have no problem with what Steinmetz said in general, except that when you talk about electric and dielectric, what? He mentioned the word thread. I'm sure that Steinmetz did not use the word thread, and that's the real problem. They used words such as field. They used the field all these years, and so here's our model. I'm sorry, this is the quantum model today for electricity, and that's the so-called field, electric field. What you have is all these electrons flowing through space, through the vacuum, right? In this case, it's a vacuum chamber. Okay, so you have the electrons flowing. And is this possible? I mean, without atoms, Because what they do, they ionize and then they send the electrons across. That's their version. They've gotten rid of the atom. They say they don't need the atom anymore. What they do it is just with electron flow, and because that's what electricity is under quantum. And if you compare that, against our model, this is our model where we have the electric field, you could say, pointing towards your eye, and what you have is perpendicular to it the swinging threads which form the magnetic field at 90 degrees exactly to the torsion of the of all these atoms that are essentially spinning in situ, a row of atoms. Okay, so that's the general model, and what it looks like under electricity, it looks more. Oh, sorry, wrong one. Looks more or less like this. Okay, so what you have is the torsion of a series of merged atoms. Okay, that's what you're staring at there. So it's not the flow of electron beads like in the case of quantum there. Okay, it's what we're saying is that the atoms are all bound to each other during electricity, and it's a torsion of an entire series of merged atoms. Okay, so that's our model, and you can see it's a little different than the other one. You need a physical object, and the physical object there are the atoms. They're bound to each other, so there's a connection between cathode and anode. But here you don't see any connection here under the quantum version. Here you see, one row of up and down row, all right? One up and down row of electrons. Why are they floating towards the other end? I mean, what's attracting them there? What physical entity meaning? Don't tell me positive is attracting negative. That's not a mechanism. What we're saying is, why is one series of one row, up and down row of electrons tied to the next row of electrons? Why are they pulling on them, or somehow? We see space between these rows. And so the question is, what's pulling on them? Or is this like throwing a baseball? Is the electron gun spitting out these particles to the other end? So the question is, what is the mechanism? And the mechanism here you can see very clearly. It's just a spinning in situ of merged electron shells. And so it's a different mechanism that we propose for electricity, so I don't really know what this fellow is objecting to. Okay? Okay, here's another fellow, and he talks about the redshift. If I can get him up here. It says, an introduction to refractional redshift and how it was confused with gravitational redshift. And it's related to the Pound-Rebka experiment, the Harvard Tower experiment, and it's written, I guess, by this guy Basile. And I don't really know what he's referring to. He's saying that there's, instead of a gravitational redshift, there's a some kind of refraction going on, and he's saying that's causing the redshift. It'd be nice if he could illustrate at least a basic idea, that way we can look at that and find out, what his proposed mechanism is. We propose this, for redshift. Okay, we're saying that, in the case of cosmic environment or cosmic scenario, if you take a rope, any rope, and you tie it from one end to the other, from one wall to another, you will see that the links become longer towards the center. And we're saying that this is what's happening. You don't have to have a galaxy recede from another. You can have the links get farther and farther apart. In other words, what they call a longer wavelength, or we call it longer link lengths towards the center of that of the whole rope that connects any two atoms. So if you have one galaxy at one other end of the universe and the other one over here, what you're going to have is those ropes that connect those specific atoms the rope should have longer links towards the center. And so there doesn't have to be a receding galaxy to produce with this, which we call tired light. Okay, and here's again, you have this situation where you have Andromeda galaxy, and it's not red shifted, it's blue shifted, meaning according to the studies, it's coming towards us. And there's a problem there because, you know, if the universe is expanding, in other words, as the establishment says, and all the galaxies are receding from each other, why is Andromeda and some of the local group, why are they converging upon us? Why are they coming towards us? And again, they have no answer to these questions. They make exceptions, but they kind of sweep it underneath the rug. They say, look, the farther a galaxy is, the faster it flies away from us. Yeah, but maybe the issue is the farther it is, the longer the links are getting. And again, all we're saying, we have a different interpretation for the same thing. They never considered it. Why? Because they never figured out that there could be a physical mediator between any two atoms. That's the whole issue. Because if they would have imagined that there is a physical mediator between any two atoms, then we can all conceive, you know, of what is known as tired light. And again, that's subject matter for another day, but tired light is what was rejected by the establishment. And we're saying it was wrongly rejected because they mediated or they simulated the event with particles. You cannot simulate tired light with particles, period. We're done. And with the rope, yeah, you can have tired light. Tired light just means that the wavelength is stretched. You know, the link is stretched towards the center between any two atoms. Okay, so that's our proposal.